Let us look at determinant of a matrix. The determinant is a scalar value or a number associated with a square matrix and is computed from its elements. So determinant is for a square matrix only. It is represented as the name of the matrix between two vertical bars. A square matrix whose determinant is 0 is called a singular matrix, otherwise non-singular. And why are we interested in determinants? Because they help us in determining whether a system has a unique, infinitely many solutions or no solution at all. To determine the explicit solution when it exists. To determine whether a matrix is invertible. That means whether a matrix has an inverse. To compute the inverse of a matrix if it is invertible. To detect linear dependence between equations. In 2D and 3D, to measure area and volume scaling. To understand preservation or reversal of orientation. So we'll look at all of these as we go along through this course. But let's first figure out how to evaluate determinant of a matrix. For a 2 by 2 matrix, let's say we have a 2 by 2 matrix A. Determinant of A is equal to the determinant of A11, A12, A21, A22 is equal to, now look at this carefully, minus 1 to the power of 1 plus 1. We are adding the subscripts times A11 times the determinant of A22 plus minus 1 to the power of 1 plus 2 times A12 times the determinant of A21. So basically here what is happening is that we are using or starting off either row wise or column wise. So let's look at it row wise. So what we do is we take the first element of the first row. We can choose any row. First element of first row, that is A11. We are taking minus 1 to the power of 1 plus 1 times A11, and we are removing the elements, or rather row and column in which A11 is, which means we are left with only A22. So we are taking the determinant of A2, and determinant of a single element is the element itself, plus again minus 1 to the power of 1 plus 2, that is the second element of the first row, times A12 times A determinant of A21, which is A21 itself. So our formula becomes determinant of A is equal to A11 times A22 minus A12 times A21. So it is taking the difference of the cross products. Okay, this is pretty straightforward. Now let's look at a 3 by 3 matrix. So let us say our 3 by 3 matrix is P is equal to this matrix. Determinant of P is equal to, so again, let's expand it along the first row itself. So we take this and this. So we remove the row and column to which A11 belongs. And we take minus 1 to the power of 1 plus 1 times A11 times the determinant of the whatever is remaining. That is determinant of A22, A23, A32, A3 plus now the second column minus 1 to the power of 1 plus 2 times A12 times the determinant of A21, A23, A31 and A33 plus now the third column minus 1 to the power of 1 plus 3 times A13 times the determinant of A21, A22, A31, A32. Now it's just a question of simplifying it. So minus 1 to the square is plus, this is odd power, minus, this is even power, plus. And we know how to evaluate the determinant of a 2 by 2 matrix. So A11 times A22, A33 minus A23, A32 minus A12 times A21 times A33 minus A23, A31 and so on. It's not necessary for us to go along the first row only. We can go along the second row also, any of the rows. So in which case we'll be going like this. So we have the determinant of P is equal to minus 1 to the power of 2 plus 1 times A21 times the determinant of A12, A13, A32, A33 plus A12 minus 1 to the power of 2 plus 2 times A22 times the determinant of A11, A13, A31, A33. And similarly for the next one as well. Simplifying it, we get this, and finally we get. Now, if we expand this and expand this and compare them term by term, you will notice that they are equal. Similarly, we can find the determinant along the third row as well. In each case, the determinant value is same. Note that minus 1 to the power of I plus j defines the sign for each term. Okay, so that was for a 3 by 3 matrix. Let's look at 4 by 4 matrix. So let us say we have P as a 4 by 4 matrix. Expanding along the first row. Let's expand it using the first row. We get determinant of P is equal to A11 times the determinant of what is remaining after removing the first row and the first column, or the row and column to which A11 belongs to. So determinant of this minus A12 times the determinant of the remaining part of the matrix plus A13 times the determinant of the remaining part of the matrix. And finally, A14 times the remaining part of the matrix determinant. Now evaluating the 3 by 3 determinants. So I'm skipping some steps and directly showing you the determinant complete expression. So as we can see, things become quite scary with bigger matrices. To make it easier, we will look at properties of determinants next, and then we will break down these steps and use proper terminology to describe this entire process. So that was determinant of a matrix, what it is, why it is required, and how to evaluate it. That's it for now.